Kids, we gotta get this straight. The only way you will be commutative is if your order has changed. Read the letters. XYZ on the left, XYZ on the right. No way can it be commutative. It's a grouping issue. All right, number 2. No. It's the additive inverse. When things cancel each other out, they are inverses. This is the additive inverse property. It's an addition problem. I'm adding 2 things to drop out. Are these your Kleenex? Good girl. Full-size, non-generic, and lotion.
None of that generics.
Right. Number 3. Number 3. Commutative. That one's commutative of addition because the order changes. It went from 5 plus 4 to 4 plus 5, or vice versa. Number 4.
Identity.
Perfect. Multiplicative identity or identity of multiplication. When you times by 1, you get the identical thing, and that's what happened here. Very, very good. Number 5. Multiplicative inverse. Perfect, Mr. Rocat. When you multiply and things cancel, it's the multiplicative inverse. Number 6.
Associative of Multiplication.
It's commutative.
Commutative of multiplication. Do not make this hard. On the left, it's 8, 9x. On the right, it's 8x9. They're in a different order, aren't they? When they're in a different order, it's commutative of multiplication. Number 7 is distributive. Everybody see that?
Is it distributive or have like multiplication after it, or is it just distributive?
It's just distributive, yes, it's just distributive. Okay, number 8.
Identity.
Additive identity or identity of addition, whichever way you want to write it is fine. Remember, when you add 0, you get the identical thing. Very, very good. Number 9. Associative of multiplication. Does everybody see why it's associative?
Mm-hmm.
Order didn't change, just grouping did. Perfect. Number 10.
Multiplicative inverse.
Additive inverse. Additive inverse. Number 11. Multiplicative inverse. Super. Multiplicative inverse. Number 12. Distributive. Yeah, it's kind of backwards, but that works. That's distributive still.
Wait, what was 11?
11 is multiplicative inverse.
Oh, I knew that.
Number 13.
Associative.
Associative of addition. Number 14. Exactly, Mr. Decker. It is the multiplicative identity. Kids, what happened? On one side we said times 1, and we got the identical thing. That's the multiplication property, or that's the multiplicative identity, identity of multiplication. And number 15.
Distributive.
That's distributive. Very, very, very good. Okay. Now, get out your note sheets and your homework. Get it all out. You got your note sheets and your homework. Somebody tell me where I left off yesterday. 2A?
Yeah.
We have to very first go.
Oh, my land of ocean. All right, well, we do have a lot to do. Okay, so let's look at 2B. I need everybody paying attention now. I'm looking at 2B. And we talked yesterday that when the question says, find this, we know what that means now, don't we? What does that mean? The distance from A to B, and we have a formula for that, don't we?
Yeah.
And we are all going to know that formula. It's one of the things we just need to
I know
know.
what I'm talking about.
So it's a square root, right? Now, what do I do here? Tell me what I do underneath this square root.
You would take 2 minus -5 and parentheses and square it, minus
Plus.
plus 6 minus 1 squared.
Perfect.
And then you,
That's it. That's the distance formula. Nobody is ever going to say to you, write the formula, but you better be able to use it, which Jabron can use it. He said, I'm going to take x minus x, square it, y minus y, square it, and that's what I get. Good work. Now, let's simplify. Here we go. What's 2 minus -5?
7,
Squared,
49,
49. What's 6 minus 1?
5,
Squared.
1 and 1.
Add them together and we're going to get the square root of. Luckily, that radical does not reduce, so we are finished. All right, we're not going to do C because, where's your note? You said you know where it is? Okay.
I'm gonna copy his after yours.
Okay, I was gonna get just a picture of it, but, okay. All right, let's go to number 3. You got the distance formula down. If you don't, you're gonna practice it until you do have it down. Now we're talking in number 3, we're talking about midpoint. Midpoint. How do we find midpoint?
Isn't it, don't x1 minus x2 divided by 2?
You are close, but I want you to be careful with that. Just open up your mind. Don't be bogged down by formulas. If I said to you, we're going to find the middle. So pretend, well, let's do this. Let's say you got an 80 on one test and you got 100 on another test. And I needed to find your middle score so I could put a grade on your report card. You got an 80 and you got 100. Do you want me to take 80, or do you want me to take 100 minus 80? No, that's not how we find the middle, is it? How do we find the middle? We add them and divide by 2. We call that averaging. Midpoint is average. Midpoint is average. Remember that. All you have to do to find the midpoint is average. And every person in this room knows how to average 2 things. How do you average 2 things? Add by, divide by. So when somebody says to me, average these 2 x's, that's easy. To average the 2 x's, -1 plus 6 is 5 divided by 2. There you go. There's your average x. You add them and divide by 2. What's your average y?
6 over 2.
6 over 2, which would be 3. That's it. So how do we find midpoint? I'm going to say it one more time. To find midpoint, we simply average. Easy peasy. Average. So look at question number 2, or B. We want to find the midpoint of these. Okay, what's my average x?
0 over 2.
-7/2. What's my average y? 7 over 2. There we go. We add the x's and divide by 2. We add the y's, divide by 2. You don't need a formula for that. You're welcome to use the formula, but you don't need it. Midpoint is average. All right, question 4, part 4. The directions kind of give it away. If I'm asking you for the center and the radius, what must this be? What has a center and a radius? A circle. This is a circle. This should look somewhat familiar to you. You studied circles last year. Anybody know what the center and the radius is?
3.14.
Tim?
X is 0, Y is 0, and the radius is 4.
You are exactly right. Your center is at the origin and the radius is 4. Now, for those of you that are a little bit like, whoa, 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 where did he get that? Let's do the next one. I think it may help you if we get through the next one. I think maybe you'll make the connection. This is also a circle. But his center is somewhere different. His center is at positive 2, negative 3. The center is positive 2. See where that positive 2 came from? Kind of the opposite of what's in there. See where the negative 3 came from? The opposite of what's in there. So if I had a circle that was x plus 5 squared plus y minus 8 squared equals 19, you would tell me that my center is negative 5, 8. Now let's back up to this one. This one doesn't have parentheses, right, like that one does. This one, there is no number added to the x. It's like x minus 0. There's no number there. That's why the center is at 0, 0, because there's no extra number attached to it in the parentheses. You take the opposite of the number that's attached to it, but if there is no number, then it's just going to have to be 0. Got it? Now, what's the radius? Now, Tim said the radius for this one was 4. Okay. I'm going to tell you the radius for this one is root 15. The radius for this one was 4. The radius for this one is root 15. What's the radius for this one? Root 19. How do you find the radius? You take the square root of this number over here. Okay, so how do we find the center?
You switch to.
We take the opposite of what's in the parentheses. If there's nothing in the parentheses, then it's just 0, right? How do you find the radius? You take the square root of this extra number, right? The equals number. Now, I want you to do that backwards. Look at part 5. What if you knew that the center was 1, 4 and the radius was 6? What would your circle equation look like? Olivia?
X minus 1 squared parentheses plus x minus
We use
y minus 4 squared equals 36.
Perfect. That's it. She did it backwards. She remembered that the center is the opposite of what's in the parentheses, and she remembered that the radius is the square root of that number. So she just did the backwards of that and came up with her answer. Got it? All right, on your paper, would you do B for me on your own paper? This is 5B. You already got it done, Berg?
Yeah.
Oh. Yeah, that's okay. So what's your answer, Thomas? Read it out loud and clearly.
Parentheses x plus 3 to the second plus parentheses y minus 2 to the second equals 100.
What do the rest of you think? Is he right?
Yeah.
Good job, Bird.
You okay with that?
Oh, can you?
Yeah.
Yeah, it's x parentheses x plus 3 to the second plus parentheses y minus 2 to the second equals 100.
Thank you.
Okay, so now we're going to get wild and wacky. Look at C. C says, write the equation of a circle. So in other words, you're going to come up with something like this, just like Thomas just did a moment ago. Write the equation of the circle. But this time, all you know is that the end points of a diameter are -1, 5, and 3, 7. So first of all, you got to remember what a diameter is. So everybody remember what a diameter is? Okay? now you're gonna write the equation of that circle. Now, Thomas just did one for us, and it was easy. Everybody seemed fine with what he said. What information did he need to know to get his answer? He needed to know the radius, and he needed to know the center. I did not give you either one. So somehow you're going to have to figure it out. This is called problem solving. So we're gonna have to figure out the center and the radius from the given information that I gave you. So I don't want anybody to say it, I want you to think for a moment, and then I want somebody to tell me how we're gonna do this. I want everybody to think for a second. I need the center, and I need the radius. I bet you probably do, but I'm not on page.
You find the midpoint of the line.
Ah, so if we were to find the midpoint of the diameter, what would that be for me? That would be the center. So let's just do that first, right? We know how to find midpoint, we just talked about it. Midpoint is average. So I'm going to average these. All right, that means add them and divide by 2. So -1 and 3 is 2 divided by 2 is 1. 5 and 7 is 12 divided by 2 is 6. So my center is 1, 6. So I can start my equation. Remember what Thomas did in his example? I can start my equation. It'll be x minus 1 squared plus y minus 6 squared. Now, equals something. What else do I need now? Well, I need the radius, don't I? And how am I going to find the radius?
Distance formula?
Distance formula, exactly. Isn't the radius going to be the distance from here to here? Or somebody might say here to here, wouldn't matter, right? I don't like negative numbers, so I thought I'd go this way. All right, so how's that distance formula work again? I'm going to use r this time, that's my radius. Square root. We got to remember this, folks. We are sunk. So I can do 3 minus 1 and 7 minus 6. Anybody else cold? I'm freezing. Okay? Everybody okay with that distance formula? So what's that equal? 4 plus 1, yeah, root 5. So the radius is root 5. Just a minute. So Katie Thomas, what am I going to put right here?
Square root 5.
Be careful. I erased my, oh here, let's look at this one. The radius was 6, so my equation had a 36 in it. So if the radius is root 5, the equation will have to have a, well, it'll have a root 25, it'll just be 5. Remember, when you write the equation, you have an x squared, you have a y squared, you have r squared. All right, Maya?
Why did you use, like the 37 as your first x? Because before you've been using, I don't know, like doesn't matter which x you use.
If I do 1 minus 3, you mean, instead of 3 minus 1? It makes no difference, Maya, because I'm squaring. If I do 3 minus 1, I get 2. If I do 1 minus 3, I get -2. And since I'm squaring, it doesn't make a difference. Does that make sense to you? Yeah. Mr. Troy?
I just use these 2 points and divide it by 2.
Perfect, you should have gotten the same thing I did. Yeah. So he said, Mr. Troy said, Oh, it's all well and good, Mrs. Ford, but I'm gonna find this distance. He can do that, but that's not the radius, right? If he finds that distance, he's gonna have to cut it in half, and that'll work fine. Totally fine. Fine. I don't know, all of a sudden I'm freezing. I'm ready to just like hibernate right now. All right, part 6. Got a little absolute value action going here. A. What's the answer? 1. When you add -3 plus 2, you get -1, but when you take the absolute value, you get 1. Be careful with B. There's a lot going on. Don't rush. Don't do silly things. Pay attention. Here we go. What's 4 minus 3? -3, but it's in absolute value, so it's going to be 3. Minus 4. The answer to the question is -1. Now somebody will say, Miss Ford, you can't be negative in an absolute value problem. That -1 is not in an absolute value. That's the answer I get when I do the subtraction.
Do you use a sign for both? You just like distribute the sign?
No, I evaluate this, and I got 3. I evaluate this, and I got 4. That sign is just there in the problem. I don't distribute it, I don't do anything like that. I just do that operation between these two simplified things. What'd you get for this next one, kids?
0.
I bet you better have gotten 0. This is 5 and this is 5, and so when you subtract, you get 0. Don't be canceling these out. You can't. The absolute value cancels that out, doesn't it? Yeah. D. What do you get for D?
14.
If you got 14, you are absolutely correct. Very, very good. Okay, we've at least got to get going on some of this here. P3. Is -2 a solution of this equation? How would I decide that?
You plug it in.
Oh, okay. What do you get when you plug it in? Does it work out?
-4 equals 8.
Let's see. We're going to do our arithmetic very carefully. We're putting in -2.
Yeah, it works.
Yeah, we're not going to be careless. We're going to be very careful here. What do you get when you square -2? 4. You get +4. What do you get when you multiply a -4 times a -2? 8. What happens when you add a 4 and an 8 and subtract a 12?
0.
You get 0. What's the answer to this question?
Yes.
Yes.
So, if it didn't equal like 2, it wouldn't be.
You know. Yep. If it's a solution, it's going to equal this number over here, whatever it is. Now, part 2 says, which are linear equations? We're going to spend a couple days talking about linear equations. What do you think a linear equation even is?
A line.
If you graph it, it looks like a line. Okay? Now, I need you to look through, there's what, A through F here. Does anybody see anything that you know isn't linear?
B.
B. And why is B not linear? Because it has a radical in it. All right, so how's one way we have of determining if things are linear or not? If it has a radical, it is not linear. Okay, so if there's a radical in it, it's not linear. Everybody got it? So we're crossing B off. Okay, Tyler, what did you say?
C.
C is not linear. And why, Tyler?
Because it has a variable and
Exactly, so another rule is no variables in the denominator. So I got two rules so far.
And D.
No radicals, no variables in the denominator. Now, be careful. You are allowed to have fractions as long as the denominator doesn't have a variable. It could be x over 2. Okay, that's linear. That's okay. This is not linear. You see the difference? Okay, so the rules are no radicals, no variables in the denominator. Okay, there's one more rule.
It'll only have one variable.
There's another rule. You're right, I hadn't thought of that with you. There can only be one variable in the problem. Okay.
What about letter D?
No, like one.
Letter D? Okay, letter D's a no, because why? We already talked about that.
Fraction.
You got a variable in the bottom, so that's out. Which one? F. Because you can't have an exponent bigger than 1. If you have a squared, boys and girls, it's not called linear, it's called quadratic. Remember that? AX squared plus BX plus C? That's quadratic. So what are our 3 rules for determining if things are linear? No variable in the denominator, no radical in the problem, and no powers bigger than 1. So would you say that problem A is linear?
Yes.
Would you say that problem E is linear?
Yes.
Yes. So everybody clear on that? So when we take our test over this, and Mrs. Ford has a little section on there that says which are linear, you will remember your rules. No radicals, no variables in the denominator, no powers bigger than 1. Now, I've got part 3 has, oh Lord, a bunch of equations. So how many are there? 1, 2, 3, 4, 5, 6, 7. Okay, so there's 7 equations there in part 3. I am going to call on Abby Brady. She is going to pick an equation, any of them, A through G, and come to the board and do it. Here's your marker, Abby. You can bring a friend if you want. You're going to do A? Fine. Everybody do A right now. Abby's going to do it on the board. You're going to do it at your seats. Everybody's doing A. Huh? Yeah.
What is it?
You can erase whatever. Okay, everybody's doing A along with Abby. We're going to check her work, and then I'm going to call on somebody else to come up and do another one. Okay, Abby got 6.
So annoying.
Anybody have an issue? Okay. Rocap, pick another one. B, Rocap's gonna do B. Everybody's doing B, right along with Mr. Rocap.
Do you care if I erase it?
Nope, we're erasing all of it. Leave Abby's, yeah, we'll erase the rest of it. Okay, you doing B?
Yeah.
Let's go. Everybody's doing B. Right along with Mr. Rocap. B.
I added.
Send me your pictures of these engaged using Associative. I don't know how you got it. Yeah, I don't know how you got it.
What'd you get?
The answer's 2. Yeah.
He got 2. He got 2. It's his answer. This is number B. Letter B. He got 2. Okay, Jabron? So are we good on that?
So I think I should have it.
Oh,
I know what I did.
Bryce Acreage. Pick another one. E? Oh, my, all right. Up on the board, come on. No, now, hurry up on the board, because who knows what time it is when the bell rings.
Do you want me to check?
It's 10.
Am I right, like a problem up here?
Yeah, erase this. Okay, Bryce is doing E and you're all doing E. Let's go. Everybody's doing E. Don't make me mad. We're gonna do that one. Let's do E right now. Do E right now. We're doing E.
Well, no. Oh, no, I was thinking.
-4 minus 4. Calculator on.
No, you added.
That's not what I got, but I could have made a mistake. Oh, no.
Wait, I did it.
-9.
I got just positive.
Yeah, I got positive. I have 11 over 9. Oh, $9.
Oh, I was looking at the way to do it.
I think you just looked from.
I had like, yeah, I think
I got 11 over 2.
Oh, okay.
yeah, you should.
I'm so like happy and like love it. I
No, because when I did this, I simply.
Yeah, I got 11 over 2.
Okay, I have the same, it's got the same
It's like a phone.
It's actually like nine.
What's minus 2? That's weird. You actually don't. Is that for Precal? But I didn't see that for a second.
Okay, Bryce got 11 over 2.
Atta boy, Bryce.
If you did not get 11 over 2, I want you to find somebody who did, and I want you to sort it out. 11 over 2 is the correct answer.
I got that.
Now, we are avoiding like the plague all the problems that have fractions in them. You got to pick, and you picked all the ones that don't have any fractions. All right? So I'll do C with you, and then somebody's going to have to come up and do the rest of these things with fractions in them. So here we go. Problem C. You can do this in one step, or you can do it in two, whichever you like best, whichever makes sense to you. The idea is, ultimately, I want to know what x equals. So I need to get rid of that 2/3. That needs to get out of there. So one option I have is to times both sides by 3. Now, did you hear me say one option I have?
Yeah.
Now what does that imply? There's other choices. This is one strategy. We'll talk about other strategies. This is one. If I times by 3, I'll have 2x, okay, when I multiply two fractions together. Now I gotta multiply 4/5 times 3 over 1. It's top times top and bottom times bottom, right? So that's gonna be 12 over 5. Now I would divide by 2. So x equals. But then I got to remember how to divide fractions. This is 12/5 divided by 2 over 1. 12/5 divided by 2 over 1. How do I divide fractions? 12/5 times 1/2.
Yeah.
I multiply by the reciprocal. So that would be 12 over 10, which reduces to 6 over 5. Now, one option. If I found this equation laying out in the hallway, this is not what I would do. Did it work? Absolutely. Will it always work? Absolutely, but I'm too lazy. That's too much work. If I found it out in the hallway and I knew I had to solve it, I would multiply both sides by 3/2. Because timesing 3/2 times 2/3 does what? Cancels. These are called multiplicative inverses of each other. They cancel. And I would be left with x equal to 12/10, which reduces to 6/5. Did I get the same answer?
Yeah.
Yeah. Somebody else who found it in the hallway may have said, that doesn't make any sense to me. I would divide both sides by 2/3. So I have 4/5 divided by 2/3. Well, we just talked about it. How do you divide by a fraction? You multiply by the reciprocal. Am I going to end up with the same answer?
Yeah.
Yeah. So all those different ways to think about it will work. All right? You just need to think about it whatever way makes sense to you. Okay. So now I'm going to go ahead and ask for a volunteer to put D on the board. Anybody feel comfortable with that? Good. And let's go ahead and put F up there too. Jerron's going to share the board, so he's going to use half of it for D, and who's going to do F? My friend Tyler will do F. Take a friend if you want. You don't have to do it by yourself. And I'm going to turn back yesterday's quizzes.
Me and Jabron.
Not me and Jabron, Jabron and I.
Yes.
One of the things you're going to learn about Mrs. Ford is have a double major. And I'm a certified English teacher also.
So you do the 3 and then parentheses?
No, it's just 6 cents.
These were worth 6 points, but you could have gotten 8.
I convinced her that it wasn't the right answer. I'm debating if I would.
Oh, I know.
I'm winging it.
Did you get 7 over 2?
Yeah.
No, I'm writing. I just write my letters.
Sloppy, I'm like,
Like I said, I write my letters.
Yeah.
Well, it was just your one you attempted. So yeah, how is he ever gonna grade us in here? Is he reading your book? Well, because we do such different things every day.
We have our own little textbook in your best one we got for free.
I wish I could.
How are the boys doing up here?
Is that your book?
Yeah, but there's a higher. There's a
Now,
where's that?
I need to talk to Jabron for a moment about his strategy. He said he was going to times everything.
I had to do 3 over 1.
Yes, you did. Now, here's another thing though. There were 2 mistakes there.
Okay.
One is, where's the problem? One mistake was he multiplied by the wrong thing, and that's an easy mistake to make. He needs to multiply by 3 over 1. Would you agree with that?
Yeah.
But because those 2 terms here, he needs to multiply everything by 3 over 1. Okay? So this cancels and he has x plus, what's this gonna make? 3/4 equal to, that's a multiply, so that's just gonna be 3 over 1 or 3. Now what's he gotta do next? Subtract 3/4. So he has x equal to 3 minus 3/4. What's 3 minus 3/4?
2 and 1/4.
2 and 1/4. Now, perfect. Make sure that if you're gonna multiply by the reciprocal, you multiply by the reciprocal,
Yeah.
and you multiply everything by the reciprocal. All right, let's look at Tyler's. Tyler multiplied both sides by 3, and he had the same thing going on, people. He had to multiply this, and he did. Then he added 12, subtracted. That looks pretty good, Tyler. Thank you very, very much. For tomorrow, boys and girls, I think we're about out of time. For tomorrow, I need you to, I made an assignment, okay, it's posted, but I need you to go back and look at last night's problems, because you couldn't do a bunch of last nights, right? You kind of have a little double duty tonight. I'm not telling you you have to go back and do last night's, but go back and look them over and make sure you can. Because if I were a betting person, I would bet that tomorrow there'll be a little quizzy poo that maybe involves things like midpoint, distance, things that we've talked about today that you absolutely have to know. So if you need to practice your distance formula, practice it. If you need to practice your midpoint, practice it. As well as doing some of this new stuff. So properties, maybe.
In yearbook? Well, yesterday we went around and interviewed. I put them on the yearbook. That's so fun. So you haven't started doing them yet, really. Yesterday we just like asked people like what they thought of yearbook. But we haven't done rocket. Find me. Well, yesterday Bananas put an entire sheet, like our entire Oh yeah. Seriously. No, Kevin Dean. They're the editors. That's really awesome. Get to be the editor. Miss Ford. Yeah. Will any of the quiz stuff be on tonight's homework too, or is it just from yesterday's homework? We should just go over the study guide.
Just know what we talked about today.
And the distance formula and stuff will be on it, or will we memorize? Need to memorize?
You need to memorize.
Okay.
I'll
make a flashcard.
already have it memorized.
I know. I just had to think about it.
Bye, Miss
Actually,
Ford.
Bye.
Have an excellent day.
You too.
Hi, you feeling sore yet?
My shoulder hurts.
My underleg arm is
Bye-bye.
didn't have a class in basement last year. I was kind of gypped.
Last year's the only year I had a math class that has windows.
Yeah. What's in there?
Oh, no, I didn't care.
Alright, so I'm no longer locked out of Boston. It let me back in.
Yeah, if you use the one line, like, use it.
Yeah, I know. But I also downloaded that app that'll let me do those streaming videos. So.
Okay, so she actually had a lesson yesterday, she told me on the phone, so you should be able to see it on your streaming video thing.
Yeah.
She was going to send a revised assignment sheet for the edition of the book that you have. I don't know if she's done that yet, or posted, or whatever she does. And she pointed out to me that one of the issues you guys might have, because she is, oh crap, my phone is still running. She does what I do. Yeah,